Hello guys, this is Julian and welcome to my channel. In today's video, we're gonna continue a new series which I forgot to tell you in the last video about Gravitation, the National Mathematics Day. So this video is the second part of our current series, new series, Genius. So in this series, on the birth anniversary of every genius, we're gonna cover some contributions made by them. So let's get started. So today is the birth anniversary of the genius Sir Isaac Newton. Yes. So actually there's some controversies. He was born on 25 December, but due to the calendar shift between Gregorian and Julian, because of that this happened. So now his birthday comes on 4th January, which is today. So let us know about him and his contributions. So let us see that he was about him, his biography. So he was born on 4th January 1643, so 382nd birth anniversary, and then in England, UK. And then he had a bad conditions from initially. His father passed away a few years back, his mother left him, so he was full alone. And then he joined his school where he was being mocked, and then he went to University of Cambridge, but sadly, there was a plague which did a lockdown, like here in 2020-2021, COVID. So because of the lockdown, Newton had to stay in his home, and then there he had his annus mirabilis, which means a remarkable or auspicious year, which he had because he discovered the entire laws of heaven, which was changed by Einstein. But yeah, so we're gonna discuss some of his discoveries. So let's get started. So he wrote a book known as Principia Mathematica, where he published a lot of laws of universe. So before that, we'll discuss about his famous law of motions. So that's easy, you all have learned it in your school. He discovered about 3 laws of motion. First is inertia, law of inertia. I'll just brief off because second is F is equals to mf. Force is nothing but change in momentum, or if you want to write in differential forms, dp by dt. And third law is F1 is equals to minus F2, where there are 2 objects. This object is putting F1, this object is putting negative F2, like that. The law in which he had told us about opposite action and reaction stuff. So these are the 3 laws, and the law of inertia states that an object should continue its path of either rest or motion until an external force applied. F equals to ma is nothing but force, is nothing but change in momentum, and then this is nothing but an action has equal and opposite reaction. So these are the 3 laws of motion. Now the second contribution is force. He discussed a lot about force. That is why he had his unit of force named after him, Newton. 1 Newton is nothing but 1 kg per meter 1 kg into meter per second square. Okay, now we let's discuss the most famous reason he is known as Apple. Gravity. And the most famous reason he is known for, gravity. So he discovered, after the apple fell on his head, that gravity, there exists some force which keeps us intact with the earth and the earth intact with the sun. So he said that this is true, and then he came up with the constant. You must know all of this. This is all basic high school stuff, where G is equals to 6.67 times 10 to the power negative 11 Newton meter square kg square. This is a theory of gravity, basically. Then he did have many formulas and that stuff. But that dp I've showed you there, dp by dt, that is from his calculus, which is the next level of his discoveries. So gravity is one of his major discoveries too. Okay, there are 2 more discoveries. Okay, which is not basic, but you can say that. So he had his Newton's formula of sound. Yes, sorry, sound meaning speed of sound. Newton's formula of what? Of speed. You must have learned in your chapter sound. I mean not sound, oscillation, not waves, sorry, yeah, waves. You must have learned your stuff about this in your chapter of waves. So according to that, velocity of sound is square root of pressure divided by this density of air. Okay, because this is nothing but bulk modulus, but yeah, it cancels out and then we have density here. So pressure by density. Okay, from here he got the value of speed of sound, which is this much. Yes, 280 meters per second square, which is wrong. Okay, I mean it was a significant step, it is a significant step towards discovering the speed of sound, but it was wrong because of his assumption that air was isothermal. Okay, which means that it has delta T is 0. Mostly, yeah, this. Okay, or we can say delta U is 0. Okay, so internal energy is 0, temperature is 0. The change in temperature is not 0. Not temperature is 0, the change in temperature is 0. So it's constant, which is false. That is why we had Laplace with the correction, which is gamma. Now what is gamma? This will all come in thermodynamics. Gamma is nothing but Cp by Cv. What is Cp and Cv? Now you ask me. Okay, so Qp is equals to m Cp delta T, and Qv is equals to, this is pressure and volume, a constant pressure and constant volume. This is at constant pressure, constant volume, and Cv delta T. So from here we can we can put the value of Cp and Cv and we get gamma, and he plugged in the value of gamma here, and then he got around 330 meters per second square, which is remarkable. So because here he considered air to be adiabatic, where the energy transfer is 0, not temperature. So this is the main, you can say difference, but yeah, but it was brilliant for Newton to come out with the value 20 meter per second square, meter per second, which is kind of correct, but very far away from the real answer. But it was a major leap in the field of, wave mechanics and thermodynamics. Okay. Now the second one more formula Newton gave was Newton's law of cooling. I mean, he was the one who was omnipresent in all fields. Now Newton's law of cooling, which is, if you are in India, in your 11th grade textbooks, the thermal, properties of matter, if I'm not wrong. So according to him, delta T is less than 40 degrees. Okay, if then minus dq by dt. Okay, change in temperature. Okay, change in energy. Sorry, change in energy is equals to delta T. Proportional to delta T. So according to him, here he gave a law of cooling where he says that as the temperature gradient increases, the energy flow also increases till 40 degrees Celsius. Okay, this is Newton's law of cooling. Okay, now let us begin with some major. These were major, leaps, but let us talk about more major leaps and more controversial ones. But first, let us talk about my favorite one, calculus. Without calculus, the entire world could not be solved. The world. We could not solve the gravity. We could not solve motion. We could not solve anything because Newton uses his own calculus, as I have showed you in the law of cooling, minus dq by dt, or maybe in force, dp by dt, anywhere. That's calculus, right? So calculus has 3 branch. I mean not branch, you can say types or tools. Limits, derivatives, and integration. Okay. These are 3 branch. Okay, derivatives have partial derivatives, integration have definite integration, that's different. Okay, that's different. We talk about 3 major, okay? Limits, derivatives, integration. What are they? What is limit? Okay. For example, you know this is a function. Okay. If the value approaches that number, if a value approaches 0, then what happens? Okay. This is a function. Okay. Let us do a 1D line. 0, 1, minus 1, 2, minus 2. So if it approaches from the positive direction, which means from here, the value of x will be equals to 0.00000000001, and if it approaches from the negative direction, it equals to negative 0. This doesn't mean the 0 is negative or positive. This means now it is approaching from the negative direction, which means the number will be minus 0.0000000. So this means that this is approaching from this direction, this is approaching from this direction. This is where we have that Zeno's This is where we can solve the Zeno's paradox, where it says that if you have a point A and a point B, and then you have to travel there, then you have to travel half the distance, then 1/4, then 1/8, then 1/16, and then it will be infinite distances, which means you cannot travel from A to B. Which is false, because when you take that, then we have Planck and all that stuff, but here we use limits. Limit x tends to 0 and that stuff, and make it 2, which is 1 plus 1. So we can travel. So this is limits. What are derivatives? Okay. Derivatives are much better. I mean, I love them best. You have a function, let us take a parabolic function. Now, then. Now, the area under this curve, this is a curve, is found by dfx by dx. Derivative. Oh, sorry. I'm so bad. Sorry. I was explaining integration there. Sorry, the slope. Okay, sorry for that. You have a point here. Okay, a point here. Now you must have learned tangents in your circle chapter. Okay, so we draw tangents here. The slope of this tangent, which you must know, is nothing but y2 minus y1, x2 minus x1, or here we use Newton, dy by dx. Here, so the thing is, you take a slope of a graph, okay, a slope of a curve. How to find the slope of a curve? This dy by dx means small. It's very small, minute. Minute in the sense, the small point. At this point, what is the slope? Slope, okay? Slope. And if the slope is increasing to double derivatives, that's nothing but second derivative of a function. And then we have partial derivatives, which is nothing but dy by dx. Sorry, del x, not d, del x. Which is also a type of derivatives. And then integration, which I was telling you before, area under a curve. Okay, this area under the curve is represented by integration. Now let us break this curve into many columns, and each column has a length of dx, which means a very small quantity. Now when you sum all of this in the function fx dx, when you take the function and sum dx till all the parts, which is nothing but integrating the fx dx, you get the area. Now this both are converse of each other, so if you integrate a function and you derive it back, you get the same function again, and vice versa. So they're like multiplication division. Multiplying a number and then dividing it, we get the same number back, same. So this is limits, derivatives, and integration. Actually, derivatives are derived from limits. You have a formula, which I'm not discussing now. But yeah, derivatives are derived from limits, and then integration is nothing but inverse of it. So I just mentioned inverse relation. You must have learned this in your AI classes, I guess, that inverse relation is a direct relation. In your mathematics classes. Yeah, so direct and inverse relations, they are inverse to each other. This gives some, for example, function, derivative of function, and then integration of the function gives the function back. So this is it. Like if you want examples, I can give you, but this is not a class on calculus. If you want a class on calculus, you can just write it in the comment section. Now, let us talk about the most controversial thing, light. So he told about like stuff about light, okay. And then before that, you might be wondering that is calculus discovered by Newton or Leibniz? I mean, it's a controversy going on that it's either Leibniz or Newton, but most people say it's Newton, most say Leibniz. I think it's both of them. Leibniz did some stuff, Newton did some stuff, so it's both. But this is Newton's video, so yeah, we'll talk about Newton here. Then we have light, the most controversial one. You must be wondering, isn't gravity the most controversial one? No. Gravity is kind of controversial, but then we have Einstein just tells stuff about curvature, which is not controversial, we just know the truth. But light is controversial. First, the most easiest fact is that he gave about colors. So different colors sum up to form white light. He gave about this fact. That is why we have that Newton's wheel experiment, where we have a disc with Newton's disc, where we have different colors: red, yellow, green, blue, indigo. Wait. Orange, green, blue, indigo, violet. And this is a random color, okay? When you spin it, you get white light, okay? This is the most, easier fact. But the most controversial fact was Newton said light were particles, which was against what Huygens, or Huygens, Huygens or whatever, he proposed that light were a wave, as of wave fronts. So you have wave optics chapter, if I'm not wrong. Like if you have light here, the light comes like this instead of like this. Light comes like this. But then Einstein came in 1905 and told about photoelectric effect. Okay. So this is how light travels instead of this. This is what Newton said. This is what this dude, Huygens, said. Okay. Now, you might be wondering that what did Newton do after that? Did he rest or something? No. Newton loved religion and alchemy. He said they were one. So he, devoted his entire life to alchemy after that. He did experiments, he read religion books, and then he just tried to merge them, and then, yeah, this is how Newton did stuff. So, this is about Newton and his contribution. It was great that Newton discovered this all stuff in 2 years, Annus Mirabilis, and then his Principia Mathematica, which is so good. If you want, I can give a link of it in the description. It's actually available. The same text and words where Newton mentioned about the gravity and stuff, and then we have all this stuff. So I hope you liked my video, and then if you want, you can subscribe, like, and share this video. Goodbye, keep learning, and let's stay tuned for the next video, which will be about, you guessed it right, 8th January 2026, which is nothing but who's ready. Write down in the comment section. So goodbye. Okay.